surface area of prisms and pyramids has been something that you've learned in middle school. And you learned that you could find the area of each face of a prism and find the area of the two bases and then add them all up, and you would get the surface area of that prism. But what we'd like to do is we'd like to talk about a formula, T equals capital PH plus 2 capital B. It's a formula that you can use to find the surface area of prisms, and it's more efficient because you don't have to break it down into the individual parts. So we have this prism here. It has a triangle for the base and another triangle for the other base. And remember that in prisms and 3D figures, the bases are the parallel polygons. They don't always have to be top and bottom of the polyhedron. In fact, in many cases, we will draw them to the side or upside down and so forth. So these are the two bases of this trapezoidal prism, even though it's not lying on those bases. They're the parallel shapes, the two parallel shapes that make up the two bases, and the side that connects them is the height of that prism. So we have our two bases. These two bases are triangles. They happen to be right triangles. And so this is a right triangular prism. And the reason it's a right triangular prism is because it's perpendicular. The bases are perpendicular to each other, not so much that they have right triangles. It's not slanted to one side. It's straight up and down. Okay, so two right triangles are the bases. So no big deal. We would usually find the area of these two bases. This has a 3 for one side and a 4 for the other. And with a triangle, the base times the height divided by 2, or 1/2 the base times the height is our area. We're going to use the capital B to denote the area right now, because the capital B means you have to actually calculate something. And so when you're calculating something, it's going to be capitalized. And so capital B is the little b times the h divided by 2. So we'll let our little b be the 4 and the h be the 3. And 4 times 3 is 12. 12 divided by 2 is 6. So we know one of these bases has an area of 6 units squared. We also know that the other one has to have an area of 6 units squared. And so our capital B is 6. Okay, no big deal. We've got 2 of those. We're going to take 2 times 6. I'm going to actually write this down below so we can talk about why this works. So our total surface area is going to be the perimeter of the base, capital P because we have to calculate it, times the height of the prism plus 2 of these capital B's, the 2 of the areas of the bases. So we found out one base was 6, we'll have 2 of those. All right, so that makes sense that the 2 capital B's are there, but why are we using capital P times H? Well, when we're looking at this net of this prism, we can see that we have a side here that is 6 and a side here that has 5 for one of the lateral faces. 6 by 5. 6 times 5 is going to get us 30. And the second one over here has a 6 by 3. And 6 by 3 is going to get us 18. And this third one has a height of 6, a length of 4. 6 times 4 is 24. So what do we notice here? Well, we're going to add all 3 of those up. When we add the 3 rectangles, means that we're going to take the height of the prism times the 3, the 5, and the 4. We're taking that 6 times the 3 plus the 5 plus the 4. Well, what is, because 6 times 3 plus 6 times 5 plus 6 times 4 is going to give us those 3 rectangles plus the 2 bases. Well, if we factored that 6 out, is 6 times the 3 plus the 5 plus the 4. Isn't 3 plus 5 plus 4 the perimeter of one of our bases, the distance around that base? 3 plus 5 plus 4 gives us the distance around our triangle. 3 plus 5 plus 4 is 12, so 6 times 12, or 72, is going to be our perimeter times our height. And again, this height is not the height of the triangle, it's the height of the prism. It's the side that connects the 2 pieces together. So we will have 72 units squared and another 12 units squared for a total of 84 units squared. And that's our total surface area. So you're going to find that, yes, you could make a net and you could figure out what all of the 3 of the rectangles are for area and find the 2 areas of the 2 bases, but it would take longer than if you start to embrace the formula T equals capital P times H plus 2 capital B's. So on your homework later on, be careful. This is the H of the base on your trapezoid. And we'll talk about formulas for finding the area of a figure. And this is the height of the prism. This one's used to find B. And this one's used to find the surface area. The total surface area. Okay, so let's talk about what happens with pyramids. Well, again, you could find the area of each face and the base. There's only one base now. And then you could add them all up. Or again, we can use and embrace a new formula. And that formula is T equals 1/2 capital P, which means it's capitalized. We have to calculate the perimeter of the base, times an L, where L is that slant height that we were talking about when we were working with cones, plus just one base now, because these triangles are coming up to a peak and they are it's a pyramid, not a prism. So why this formula works again? Well, let's look at our base. In this case, we've given you a square base, and so the square base has a distance around that is 4 of these 4 by 4. Adding 4 plus 4 plus 4 plus 4 is the same thing as multiplying by 4. And so we're taking 16, which is the perimeter, times the slant height. Well, why would we use the slant height? Well, let's talk about how this would work if we were actually working this out by using the net and finding the area of each triangle plus the area of the square. So area of the square, no big deal. B is our area of our square. 4 by 4. Okay. We would have to find that if we used the net or if we didn't. But we also have to find the area of 4 triangles. So we're going to take 4 times the area of 1 triangle. Well, the area of a triangle is base times height divided by 2, or 1/2 the base times the height. And this is not the height of the pyramid now, this is the height of the triangle. And that height of that triangle ends up being the slant height of the prism. So this height of this triangle is 6.3. So we're taking our base of our triangle, 4, times 6.3, and we're dividing that by 2. And we need 4 of those because they're all identical. 4 congruent triangles. So why does that work to become 1/2 PL? Well, our L is the 6.3. And so we can see that there. We see the 1/2 we're dividing by 2. And so isn't the perimeter of this particular figure 4 by 4 or 16? 4 plus 4 plus 4 plus 4. And that's why the formula works. So let's finish working it out. The total surface area is going to be 1/2 the perimeter of the base times the slant height plus the area of one base. So 8 times 6.3 plus 16. Plus 0.4 plus 16 should be 66.4 units squared. Okay, so really crucial that you remember when you're finding surface area, total surface area, use the slant height. Okay, it's different when we're finding volume. So let's talk about finding the volume of a prism and a pyramid. When we want to find the volume of a prism, we use the formula V equals capital B times H. And again, capital B means we're calculating an area. It's the same base that we found when we found the surface area. So we could go back and find that capital B. This is the same problem, same prism. We found out that our base, and it's really good for you to say, hey, if I'm going to find these guys, I might as well put a big B out here equals 6. We found that before, but we might want to box it in, because if you're working on surface area and volume of the same figure, you're going to need that number anyway. We found out that the area of the base was half the base times the height, which was half of 4 times 3, and half of 12 is 6. So our capital B was 6. And now we need to figure out what the height of the prism is. So this is not the height of the triangle, this is the height of the base. The height of the prism is the one that connects the two bases together. So this is the height of the prism. It's important to keep them straight. So we're taking our base that we found earlier, the area of the base, times the height of the prism, and 6 times 6 is 36 units cubed now, because we've taken the half the base times the height, units times units, and then we've multiplied it by the height of the prism, which gives us units cubed. Volume is measured in units cubed, centimeters cubed, and so forth. All right, so we'll come back and talk about the area of each base and how to find those in just a moment. But let's talk about the volume of a pyramid now. Okay, when you're finding the volume of a pyramid, the volume of a pyramid is 1/3 as big as the volume of a comparable size, shape, dimensions prism. So the pyramid is 1/3. So if I had two figures, two 3D figures, two polyhedrons, and one of them was a prism, same dimensions as the pyramid, it would take 3 of these to fill the prism. That's why it's 1/3 as big. So we're just going to plug this formula in and say, all right, I need to find my volume. I know I need to take 1/3, or when I'm all said and done, I can just divide by 3, of the area of the base, and then we need to take that times the height. Well, it's the same base that we found earlier for our square. So 4 times 4 is 16. So 1/3 times 16, and then we need to take that times the height. But we have a caution symbol here again. The height is the perpendicular height, meaning from the vertex of the pyramid down to the center of the base. So it's not the slant height, the 6.3 that you would slide down if you were sliding down this pyramid on a rug or something like that, but this is the perpendicular height. And so it won't always be given to you. But we have a right triangle here, and we know that the slant height, the hypotenuse, is 6.3, and we don't know the height of the prism. It's often shown as an H. In my case, it ended up being an M when I constructed this for you. And we do know, though, that if we go from the center to the midpoint of the opposite side, that we're going to be bisecting this, or we're going to have a distance of 2. If the whole distance across this base is 4, this leg of this right triangle will be 2. So, good old Pythagorean theorem to the rescue. A squared plus b squared equals c squared. Apologies for my typo. And so we're going to say 2 squared plus h squared, in our case, is going to be equal to 6.3 squared. And when we work this out, we will have 4 plus h squared equals, and I don't remember what 6.3 squared is off the top of my head. Good old algorithm. All right, 38.69 if my calculations are correct. And so when we subtract, we'll have h squared is 34.69. And taking the square root, we did something wrong because it should come out to be 6. It should be 36 when it's all said and done. So I've made some calculation error there, and I apologize for that. So our height of our pyramid is actually 6. And so we'll take 1/3 times 16 times 6. Let's go ahead and simplify. 1/3 of 6 is 2. 2 times 16 is 32. So 32 units cubed. Okay, so coming back up here, let's talk about the area of the base. Remember, capital B is the area of the base. So you can start thinking about your formulas for finding areas of various two-dimensional figures as being a capital B instead of a capital A. If I want the area of a rectangle, I'm going to take the length times the width. Area of a square, side times side, side squared, or length times width, base times height, whichever one you want to use. The area of a triangle is going to be half the base times the height, and that's a little b, because it's not calculated, it's a number that we're pulling in, or you can also call it base times height divided by 2. And then for a parallelogram, we're taking the base times the height. We could grab this triangle, bring it over here, and now it's nothing more than a rectangle. And so the area of a parallelogram is the base times the height. And finally, for a trapezoid, to find the area of a trapezoid, you have to take 1/2 the height times the sum of the bases. And remember, this is the height of the base that we're working with, not the height of the pyramid, prism, whatever you're trying to calculate. So we call them b sub 1 plus b sub 2 because there are 2 bases. The parallel sides are the bases, and half the height times the sum of the bases will give you the area of that trapezoid. All right, you have everything you need to know to do well with this. So good luck